Hello and welcome to the next lesson. Case study number 13, Dynamic Pricing Marketplace. Let's get started. Bronwyn, a serial entrepreneur, wants to build a simple dynamic pricing marketplace where sellers can list products and buyers can purchase them. Bronwyn's goal is to create a system where product prices automatically adjust based on demand, supply, and other predefined criteria, ensuring fair pricing while maximizing revenue for sellers. They envision a straightforward platform that prioritizes functionality and scalability. Here are the requirements. Create a pricing engine that changes prices automatically based on demand, inventory levels, and rules set by the seller. Set up access controls for sellers and buyers to keep data secure and private. Make sure the system manages product listings, transaction history, and pricing rules effectively. Provide real-time notifications for price changes, inventory updates, and transaction statuses. Add an analytics feature to track sales trends, pricing effectiveness, and user activity to help with decision-making. All right, now let's go to the system design. Once again, we always start with the user, okay? So again, anytime you're talking about a marketplace, the ability for people to, have prices and things of that nature, even though it might not have been explicitly stated in the system requirements, we put an authentication service in there because we want to make sure that people are exactly who they are, especially if they're going to represent, if they're going to be able to buy and sell from this area. So that's what we want to do. So of course we have our service backed by a key value store, and we're going to call it the authentication service. Okay, give me a second to move this up here. Authentication service. All right. Okay, cool. So next, it seems a little bit standard for most of these applications. We're going to have a web service over here. That's going to be a central hub of where you activate the things that you want to activate. Now, if we're thinking, again, you have a marketplace. What are the things you need to have? You need prices. With products, right? So you need product description, product prices. You need like images for the prices and stuff like that. And then if you want to actually buy something, you want to like go ahead and have an ability to put your credit card in and your bank information to do so. So we've been through this in a few other things we had. We had an auction-based marketplace earlier. We had an online store earlier as well. So you'll see some of these similar concepts, similar building blocks, system designs as those. So first, we go ahead and we're going to need a structured database to have that data about prices, about products, and things of that nature. So we have our service backed by a relational database, and we call that the data layer service, as we've done before. And then as I've done with a few of these case studies before, in order to really, bolster the understanding here, we'll give multiple names. We give it the product price service. Because the whole thing here is that, like, again, the previous lesson, in previous case study, we talked about auction marketplaces. This is when, again, like when prices aren't fixed because people are bidding now, the system itself is changing the price based on rules set. This is, so therefore, this pricing service is going to be something that is going to be housed here in the database. You're going to see why that, in the auction-led one, we had like a product price data data service that was a key value store because we wanted to make sure that people are able to like outbid each other, and those actions happen in real time. So we really wanted a fast store. Whereas here, you'll notice that this is actually the product price is going to be stored into the database, but you'll see how, in this case, how the price changes. But before we get there, let's go get the other, building blocks in place to have a proper online store or marketplace. So again, you need that structured database. We also need a raw file store so that we can have product images and whatever else makes sense to add to products. So hold on, go ahead here. Excuse me. And then you have the raw file service over here. Okay. And then last but not least, again, like you want the people to have the ability to, if they find something they like, they can actually buy it. So, and again, we don't want to reinvent the wheel and have to figure out how to accept every credit card and all the checking and savings accounts and whatever else is out there. So we connect with an external API, back it by our own service so that our internal application has standard APIs that we understand and we use to interface it. And we call that the external backing service. So let me just clean this up a little bit, move this over here. We call it the external banking service. So this should look familiar. If we have this somewhat set up in a few of these case studies, and that's the other thing that I want to like kind of highlight. This is case study number 13. There's all these different applications, but there's similarities. There's things that are common. There are things that go together. There are things that don't sometimes. This is a whole point about like gaining that senior intuition. Look at the patterns, see the patterns. The idea of moving to these building blocks, these 7 building blocks, is that it makes it really obvious. Make it like, let your eyes kind of like make the connection when you see the same blocks together in similar products. These are things that do go together. So really want to understand and take this aside to understand that the reason why we're designing in this way with these blocks and these colors and stuff like that is to help your mind start to see similar shapes, similar patterns to different applications and get the intuition that typically senior engineers have after years of doing and building applications. So let's move this web service over here to that. This web service also will need to be connected to the raw file service. Over here, let's see if I can make, okay, let's see if this is going to make this hard for me to do. Okay, maybe I'll do this. Okay, and all right, here we go. Oh, here we go. Awesome. So now we have the external banking service and everything connected up. So right now we have, let's say, so not this yet. So set up access controls for sellers and buyers to keep data secure and private. Yep, that's service. Actually mentioned that it wasn't in the requirements. Actually it is right here. That's why you have the authentication service connected to everything. Make sure the system manages product listings, transaction history, and pricing rules effectively. Most of that is handled in this data layer service. Now we're going to start getting into the other items. So first, like we have this provide real-time notifications for price changes, inventory updates, and transaction statuses. So you want to be able to alert the user like, hey, there's low inventory or what have you. So what we'll do with that is, as you see, like we've had this pattern before, if we want to notify the user, then we have a notification service that the user can subscribe to. So the user can just say like, oh, hey, I'm interested in these products. I want to make sure that if they're low, I know, and things of that nature. So that's the service here. Now, here's the thing, like I think in the previous case study, an auction-led marketplace, I talked about notification workers. And in that case, the auction itself wanted to push a notification to the user. So therefore the queue was filled in by the user, and then a worker went out and that notified it. And that was the pattern here. So this is going to be a little different. It's just notification service. And in this notification service, the user itself subscribes to like, oh, I want to subscribe to a specific product. And then this will make sure that, and all the updates are happening in the notification service. And when it has that subscription, it's like, okay, cool. I know that I'm going to get that information to, like I know that user needs it. So I'll make sure that, the user is subscribed to the right message in order to get so. The difference between a service and worker, a service has the ability for a user to interact with directly. A worker does not. It gets kicked off by an external force. So those are the difference between the two things, if you were wondering. So we have this, connected to this, to the user, and then we go ahead and connect that to the web service. And all of a sudden now, the web service now is connected to the notification service, connected to the user. The web service can make sure to provide like the streaming updates of what happened, of the products. And if the user wants to be subscribed to some, product updates, it subscribes to it and gets those notifications through there. It's a very efficient way. So we have that real-time notification set up. Now we're talking about now the idea of product dynamic pricing, a pricing engine that changes prices automatically based on demand. What you'll see in the appendix is an equation that, like a simple equation that's based on having thresholds of inventory, and if the inventory is too low, too high, the price increases or decreases in order to meet demand. Something very simple and straightforward. That can be more complicated, and you also can add rules, user set rules as well. Maybe the user can adjust those transactions. All of this it will be set in the data layer service. But the way we'll implement this is, again, everything doesn't have to be the fanciest, crazy, real-time processing, so on and so forth. If we are adjusting we're adjusting prices based on, let's say, inventory, what we can do, another thing we can do is simple. You actually won't see it have a separate pricing engine here. What we're going to do here is we're going to have a time element based on a worker or workers, and then we're going to call this system. Hold on. We're going to call this system, if I can just double tick this, pricing update workers. And this is going to be interesting, connected to this data layer service, right? Our product price service. And this is going to go back to the web service. And this does something interesting. What this does is okay, hold on. Let me just spend some time getting these lines right while I talk through what this does. Let's just do this one, I guess. Okay. Okay, that's better than the alternatives. Okay, and then maybe I'll move this here. Okay, cool. So what this does here is that let's say we set an increment, maybe 15 minutes, maybe it's every minute, so on and so forth. And during the triggers in which a price should be changed, in like the appendix, we have it like if there's inventory is too high, we could lower the price, or if inventory is too low, we can increase the price. It queries the database, the data layer service. It gets a list of all the prices that are above or below threshold, and makes that connection, it makes that correction, saves it back to data layer service, notifies the web service, and all of a sudden, and then that also sends a notification to anybody who's interested that the price just changed. Now, all of a sudden now, you have this crazy, like the engine is basically stored in the logic of the workers. And periodically it checks the database to see and see if the conditions are set. And if it does, it updates the price. This simple way gives us this dynamic pricing marketplace where the engine logic is stored into the instructions that are held or executed by these workers. So here's yet another way of how you can have a dynamic pricing marketplace. So I think so. We have a pricing engine that changes price automatically based on demand. We have access controls. Make sure that the system managing product listings and transaction history, mind you, transaction history can be saved in the data layer service as well. We have real-time notifications as well. And then now we have this data analytics feature. And again, you're starting to see this in a few of the previous case studies. When we have an analytics concept, the idea is that somebody wants to go in and be able to play with the data, figure it out. You have your data scientists or data engineers that really want to look into data and see what's there and make something happen. In this case, right, it is really, really great. You'll see this over and over again to like have a separate store where people can log in a separate area and do their queries. Because the last thing you want is people doing live huge queries, so much so that slows down your main system, and now people can't buy things from your store anymore. So in this case, what we do is that we actually implement this system is going to do this by adding another time element with another worker. I'm going to call this audit log workers. We connect the data layer service to this. This audit log service runs periodically, let's say every 15 minutes or whatever, looking for any new transactions it hasn't processed yet. It gets that, and then it stores it in a audit log service, which is a file store. So in single files, okay. So we have this over here. Again, there's many ways to do this. So this is the way that we're doing it in this design audit log service. And then all of a sudden, what we're going to do in this is that we're actually going to take Bronwyn directly to have access to this analytics web server. So we'll put another user. Let's put Bronwyn's name here. Hold on. Copy, paste. Here we go. Bronwyn. Okay. And then again, as you can see, there'll be like another analytic web server that's just dedicated to that. Analytics web server. And then we'll have analytics search queue workers. So that every time that Bronwyn does a request, it kicks off a worker that does the heavy lifting of searching the audit log service. And it's okay because you have one person sending a worker, it's working with the audit log service. It's not blocking any of the actual systems that's running the marketplace. So this can run for hours and hours and not affect anything, which is the goal. So I know what I'm calling analytics search queue workers is what I'm gonna call it. Let me just delete the rest. Make this wider. All right. And then that connects to the audit log service. So let me go ahead and connect Bronwyn to analytics web server, to analytics search queue, to audit log service, which is being populated by audit log workers that regularly ping the data layer service. And then you have it. We have this system where we have a dynamic marketplace where people we can load load products whose price changes dynamically based on these pricing update workers, and also have a separate analytics place where we can analyze transactions as well, and it doesn't impact the core application. All right, so that's our design. Let's go to our key takeaways. First key takeaway: dynamic pricing algorithms do not have to use AI. They can update prices quickly and efficiently with predetermined rules and data calculated promptly on demand. Examples include inventory and user demand. We can benefit from storing this data in a structured format, so we use a service connected to a relational database, the data layer service, also called the product price service. Second key takeaway: the price of products can be dynamically changed depending on a number of parameters. Thresholds are typically employed as triggers to determine when a product price is to be recalculated. We use scheduled workers to periodically query the product price service to determine when conditions are below or above the threshold for recalculation. If conditions warrant it, the price is recalculated and an update is sent to the notification service. Third key takeaway: some applications need a separate system to study transactions so that analytical queries do not affect their operations. We set up an analytics web service that fires off audit log workers that query the audit log service, which is separate from the data layer service. To populate the audit log service, we set up audit log workers that periodically save recent transactions from the data layer service to the audit log service. This practice helps reduce the load on the database and allows for complex queries without slowing down the system. Thank you so much. See you at the next one.